Hello and welcome to today's SQL Office Hours session. Let's start with a question that you may have been asked or want to answer sometimes after doing a data load. So you've copied some data from some staging area into the main tables. And the question here is, do the tables match? Have they got the same data, right? Ideally, the answer is yes, they are identical and they have got the same information in them. But it's good to verify that. It's good to check and say, do the two tables really actually have the same data in them? So the question is, well, how do we do this, right? Well, we'll start off with one approach. The classic approach is using set operations. So what we'll do is we'll query the two tables. I'll just call them T1 and T2 for now. They could be anything. So we select all the rows from T1 and then minus off all the rows from T2. So that gets us everything that is in the first table, but not in the second. So that's what minus does. It kind of subtracts, right? So that gives us all the rows that were in the first table, not in the second. So that's kind of half the problem, right? Everything in T1, not in T2. We want to do the reverse as well. So essentially, we just need to flip the operations around and say we have T2 minus T1. So this gives us everything in the second table, not in the first. So now we've got our kind of two data sets. Everything in the first table, not in the second. Everything in the second table, not in the first. To return that all as one query, we just union all the results together. So we can have a process a bit like this. Each table minus the other, and then union the results together. So as a SQL statement, that would look something a little bit like this. And I've got the parentheses around this just to ensure we enforce correct order of operations. Now, like I say, this is fairly straightforward and it's the classic way to do this, but there's a bit of a problem here. Well, there's actually a few problems, but one of the more obvious ones is we're reading all of both of the tables twice, right? You can see we're querying all of T1 and all of T2, both of them 2 times. That sounds like a lot of wasted effort, right? So the question here is, well, can we do any better? Is there actually a way around this? Can we read each table just once and still compare them and see what the different rows are? So make yourself comfortable, pour yourself a drink, whatever. We're going to explore this question into today's SQL Office Hours. So let's find out and walk through this process. So hi, everyone. I'm Chris Saxon. I'm part of Gerald Wenzel's developer advocate team here in Oracle. It's my job to help you get the best out of Oracle database and hopefully have some fun whilst doing so. So with that in mind, like I say, what we're going to do today is say, how can we compare two tables and check if they've got the same rows in them? And if they don't, return the different rows. So show the differences between two tables. And we start off how we could use set operations, but there are actually a couple of other ways we can do this. The first is we're going to use a join. Right? And at this point, you might be going, well, how does that work? Right? Well, how can we use a join? Well, start off with, we'll query each table. And for each one, we'll add an expression, a column to it, which is just a constant, a string saying the source table name or some identifier so we know where the data comes from. So we're selecting all the rows from T1, but we're also adding a column T1, which is just the value T1, and T2, which is just the value T2. So that could be, jobs and job stage or whatever the tables are that you want to compare. We will then full outer join these two tables together on the columns we want to compare. It's like, interesting. Well, how does that work? How does that help us? Well, when you join tables together, you get the matching values from each table are combined together, right? So we can see the values that are the same in both tables are returned as one row. So that's a classic kind of inner join. But with a full outer join, we also get the rows from each table with no matching row in the other. So we can see we've got these T1 rows at the top. There is no matching row in the T2 table, so those values are null. Similarly, for the T2 rows, there is no matching row in T1, so the T1 values, these columns that we've added to the result, their values are null. So to find the mismatches, the rows that only exist in one table but not the other, we can filter the results of this join to find the rows where either of these columns are null. And voila, there we are. We've just got the different rows, the differences between them. So that's kind of like the overview of how that works. What does that actually look like as a SQL statement? Well, as I said, first up, we want to query the tables, and we're just going to add an expression saying what the source table is. It kind of, you can put whatever you want here. It's just something so you know, or that these are different things, so you know which table the data actually comes from. And then we are going to full outer join them together. But there could be a lot of columns in these tables, right? And writing out all those columns could be a bit painful, right? Maybe if there's 2 or 3, it'd be okay. But let's say there's 30 or 40 or whatever. Writing out that join clause could be quite painful. So there is a guy called Lucas Eder, and he came up with this nice little trick that you could use to do this, to automatically generate it for you. And that is a natural full outer join, right? So those of you familiar with a natural join, the database automatically generates the join clause based on the column names. So it looks at the column names in T1, looks at them in T2, and those columns that have the same name, it automatically creates the join clause for them. So it automatically compares them and makes them equal. Good thing about this is it's nice and super easy to write, right? It doesn't matter how many columns there are or what our tables are called. It just works as long as they have the same columns. However, like I said, this only works in some very specific circumstances. And that is when the columns have the same name, the tables have the same named columns, and they're all mandatory. If there are any nulls in either of these, then the query will break, right? So in order to do this, you have to meet some very, very specific criteria. If you don't meet them, then this approach won't work. You'd have to like manually write out, join on blah, 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 blah. So I see someone saying a question, since which version? This is very old. I think it's since ISO joins were first added back in 9i or something like that. This has been around a very, very long time. Okay, if natural joins don't work for you, you seriously need to upgrade. Okay, it's been around a very, very long time. Okay, so like I say, it's super simple to write, but there are some very specific criteria. The tables have to have the same column names, and there can't be any nulls in those results. And so this, having the same column names, we could probably manage, and that would be okay in some cases. But dealing with nulls, quite often tables will have at least a few optional columns in them, right? So it would be nice if, instead of having to write out all the columns individually, all the join clauses, there was another easier approach. The good news is there actually is. We can convert the tables to JSON objects. So with JSON object, the function was added in 12.1, I think. In 19C, sorry, we added this simplification, JSON object star, that automatically generates a JSON object for all the columns returned from the table. So this is a little 19C simplification that you need to use. If you're on earlier versions, or again, if the columns have different names in the tables, you will still actually have to list them all out manually to give them the correct names and aliases and so on and so forth. But this is a nice little simple way of doing this. And it's like, well, okay, how does this help us? How is this going to make things easier for us? Well, you can now make the join on the JSON equal function. So this was added in 18C, I believe. And this compares two JSON objects and asks, are they the same, right? So again, we're joining on that, and we want to return the mismatches. So at this point, we're going, okay, well, why do we want to do this? What advantage does this have over the natural join or manually writing itself? Well, compared to writing it all out yourself, again, it's a lot easier. We don't need to know, as long as the column tables have the same names for those columns, we don't need to know what they all are. But it automatically handles nulls. Those attributes will be in the JSON document object with the value null, and JSON equal just compares across the whole thing. So it automatically handles nulls. And it has a nice little advantage. And one very specific reason I'm showing you this, it is lob safe. So if there are any clobs or blobs in these tables, it will handle them automatically, which is not the case for a lot of these other approaches. So I see someone was asking about this. If you want a lob safe way to compare tables, this is a very useful way of doing this. So this is pretty neat and can be pretty useful as a way to do this. So that's one approach. We're using a join. We're doing a full outer join of the tables. We're adding an expression to say the source, full outer joining them. And then however we write the join clause, whether it's natural, qualified, you write it out, or using JSON, we are comparing the matching rows between them and then find the mismatches where those columns are not. So that's one method. Method two we're going to look at today is grouping. Okay, so rather than joining the tables together, what we'll do is this. Again, we're going to add some expressions to each table, so the source tables. So this time we're going to add two, actually, one for each table. T1 for our first table, all the values are going to be 1, and there's 0 for T2. And then for our other table, we're going to flip those values around, so it's 0 and 1. So it doesn't matter which way around they are, really, just as long as they're all 1s for one table and all 0s for the other, and they're the opposite way round on each table. Having added those to our queries, we can then union them all together to give our overall data set. Then to find the mismatches, we can group by the comparison columns. So we're going to group by these columns in the middle, whatever they happen to be. And then we want to find the ones where the sum of these columns we've added are different. They're a mismatch between them. So we group by whatever the columns we want to compare are, and then use the having clause to find those where these T1 and T2 sums are different. So notice, like our green rows, the values are 1 for all of those. They're 0 for T2 and the opposite for the other table. So again, what does that look like actually writing that as proper SQL? So we've got our statement like this. Select our columns, and again, doesn't really matter which ones 0 and 1, just as long as they are the opposite way around for the other table. So we've got 0, 1, 0, 0, 1. And then we will group by whatever our columns are and have the having clause to check the differences. So this is probably my favorite way, actually, to compare the tables. Why? Well, it's automatically null safe, right? If you're grouping rows and any of them have the value, any columns have value null, then group by considers those to be equal. This method also has another benefit, which the others don't have, at least by default, is that it shows duplicates. Let's say the same values exist in both tables. So T1 has 2 copies of a row and T2 has 1 copy of that row. Normally, you'd want to see the extra row, right? With set operations and joining, they won't show that. They'll just show, yep, that value exists in both tables. So by default, it will hide it. Whereas this grouping approach, we will see that there is an extra row. So it automatically handles duplicate values, which is a nice little advantage of this. So that's kind of an overview of how they actually work. Let's jump into and actually see them properly. Let's see them in action and actually use them for real. Let's just move on. Okay, so let's bring up my demo. So someone asking about lobs, mentioned the lobs there, and someone asking about how much overhead. We'll come back to performance like at the end. All right, so that's something we'll talk about later. So we got our jobs table, we've got 5 rows in it, and our jobs stage table, again, 5 rows in it. The question is, are they the same? Now, even with just 5 rows, it can be a little bit tricky to spot the differences here. So let's start off with, let's break it down. Our classic approach, jobs minus job stage, everything in this table, not in that table. See, there's 2 rows there, and the reverse, stage minus jobs. So again, we can see there's 2 rows, and if you're the eagle-eyed among you will have noticed that IT programmer appears in both tables, but they do have different maximum salaries, right? So let's bring them all together, union them all, and there you go. You can see this job ID is in both tables, but there is a different value for the maximum salary. So this is something that could be a problem if there's lots of columns in these tables, you know, like 40 or 50 columns, and only 1 or 2 of the values are different. Can be tricky to spot. We'll stay tuned. We'll look a bit later how we can do like column level comparison and see actually the columns that are different for each one. So there we go. There's the classic approach. And like I say, we were reading all of both tables twice. Can we do better? Well, oh yes. The another thing to mention actually is we don't know which table the values come from, right? So we've got accountant, but is that in jobs or job stage? we actually don't know, right? So we can add, as we did with the other ones, add an expression to say the source table. So we can see that accountant came from T1 and the values T2 and so on. All right, let's look at our natural full join. So again, just to break it down, first up, I'm just querying the tables and adding a column to say the source. Say, I mean, I've called them T1, T2. Really doesn't matter as long as they're different. So, you know what they are. And we are natural full joining it like that. And now at this point, hopefully you can see that, the values that are in both tables, these columns both have a value, right? The value that we've just supplied here. For the mismatches, the difference, one of them is null. So we want to filter out and show only those differences. There we go. And voila, we've got the different values for them. And also, we've already automatically got which table they were from as well. So we know what those differences are there. Big advantage of this, like I say, is now we are querying each table just once. Okay, so that works. As I said, the tables have to have the same column names, but also all the columns cannot have any nulls in them. So let's just check and see what happens if we set max salary to null for all rows for both tables. If we do a full join, it's showing us everything is different. And I was like, oh, why is this? Well, basically it's generating a join clause and it's saying, is the max salary for jobs equal to the max salary for job stage? They're both null. Null is never equal to null. So the answer is, I don't know, right? It's not true. So it doesn't return it. So if null values are possible, rather than a natural full join, we could actually do a qualified join. We can actually go the longhand way and write it all out manually and have an MVL or some null handling as appropriate. So we can do that and we can now see the differences here. Now this also kind of highlights another small advantage of the natural full join. Notice all the columns are duplicated, right? With a natural join, it automatically deduplicates those join columns for you, which again, just makes things a little bit easier, but could be potentially a little bit risky. So I know lots of people kind of hate normal natural joins. I'd love to hear what people think about these natural full joins for comparing tables. Let us know in the comments to see what you think about those. Okay, so we can write the join out like this, but as we can see, even with just 4 columns, this is getting to be quite a lot of work. So let's look at our JSON approach. I say from 19C, we can just automatically convert a row to JSON by using JSON object star, and you can see there's the JSON data. And the null values that appear as attributes with the value null. So now if we do our JSON comparison, we're going to have our join clause, it's a little bit bigger here. We're doing JSON equal. And we run that, we can see we get now just the different values between them. Now, again, at this point, someone was asking about overhead and performance and so on. I'll talk more in detail about performance later, but you'll notice I'm also joining on the job ID. I'm not doing just this, just JSON equal. Why? Well, if we do just JSON equal, it severely limits the optimizer's options for coming up with a good plan. And even on pretty small data sets, performance can be pretty horrendous. So I would thoroughly, if you want to do a JSON comparison, include some other column in the join clause, just as a normal join. Ideally, that would be the primary key, because without that, it very quickly performance falls off a cliff. But we will talk more about performance right at the very end, so stay tuned to hang around for that. Okay, so that was our JSON comparison, and we can see it automatically handles nulls. Let's look at our group by. So again, we've got our group by, we've got our ones and our zeros. So first table 1 and then 0. Then we're going to do the opposite, 0 and then 1, and then combine them all into one data set. And if we then group by those and get the sums, so hopefully you can start to already see what's going on here. So again, group by, null values are considered equal, and the rows that exist in both tables both have the value 1 for this sum. We want to find the ones where there's a difference here, like 0, 1, 1, 0. Okay, so we just do that by adding our having clause here. Got the having clause, and there we go. We've got our differences in there. Let's just roll that back just to kind of show that it works for normal values as well. So we can see we had the different salaries before. Again, we've got a mismatch. So we know this IT programmer, the row exists but one of the columns is different. Okay, so so that's kind of the basics. But as I said, one of the big reasons I like group by the most is it automatically handles duplicates. Let's just add an extra row for one job into each table. So we see we've got jobs, we got 2 rows for the account manager, they're identical. And for job stage, we've got 2 rows for sales manager. Again, they are identical, but there is only one of the other row in the other table, right? So one of the tables has 2 copies of the row, the other has 1 copy of the row. We want to see the extra row. Now, because, so let's look at them. Now, minus deduplicates. So this is effectively doing a distinct operation. So we've got our accountant, and we can see it's just deduplicated those values. So we don't see the extra row for that. So we're not seeing the extra values that we got there. Okay, we don't see that there are 2. I'm trying to remember. I've got myself a bit confused. So accounting manager, there was 2 rows for accounting manager in jobs. That row exists in job stage as well. We don't see that. It doesn't return that row because it just deduplicates that. So that means when we get the whole overall thing, we don't see those extra rows. Now, nice little enhancement in 21C is the minus all option, right? This all keyword was added as well. So then that does handle duplicates. We see any excess rows in one table and not the other. So we can see accounting manager and we can get that information there. So this is solved in the classic approach in 21C, but I expect most, if not all of you, are on 19C or earlier. So you're going to have to wait a little while to do that. So what about the full join? Again, duplicates are not shown because it compares the rows and says, well, I've got a match on those columns. Well, fine. You know, there is another row, so it joins them together. And we don't see the excess rows. In order to see the excesses, we need to add something to make them unique, okay? So basically just a row number like this. So we can add a row number. Here I'm partitioning by job. I mean, technically job ID should be the primary key here. It's not, I haven't actually added a primary key, so we can have duplicates. In the real world, we probably would list all the columns. So it should be job ID, title, salary, min-max salary, and so on. I've just done this to save myself a bit of typing and make things a bit easier to read for you. Now, because the rows are entirely duplicates, it actually doesn't matter what we order by, really. We just need to know that there is one extra. And the key thing here is now, notice, the extra row has the row num 2 for our extra account manager, right? So if we now do the join, an actual full join, and add that to both the tables, at last, we can now see the extra rows for the sales manager and the accounting manager. So there are ways to handle these duplicates and make them appear. However, with our group by, they just fall out automatically. We are checking the sums, right? For the extra row for accounting manager, the sum's 2 and the other one it's 1, right? We know there is now an extra row for accounting manager. So we don't need to do any special handling. We don't need to remember, oh, do I need to add row number or anything like that to make those duplicates actually appear. Alrighty then, move on. Just finish up on the little thing. Add some clobs, right? Now this is, someone was asking about this. What about clobs? The classic, the kryptonite of these comparisons. Unfortunately, it breaks pretty much all of them, right? If we do this classic, set operations, we get an error. If we try the group by, and again, well, lovely. We also get an error for that one. Isn't that wonderful? Okay. And the same for joins. Oh, right. Basically, clobs break pretty much everything. However, there are ways around this. I mean, we can manually write out the join and use dbms lob compare. That does the job, but again, it's fiddly and we need to remember which columns are the lobs and know what they are. When it comes to JSON, however, because that would be large data, could be a clob or a blob, that JSON equal automatically handles those values, those lobs and clobs. I'm returning it as JSON. So in 21C, we added the JSON data type. This is highly optimized format for storing or managing JSON data. If you work with JSON, we should just use it basically. But even now, though, because there are lob columns in there, JSON equal just handles that. And haha, it just works. We don't need to do anything special to handle those clobs or blobs. So this is kind of why I'm mentioning this, because in these situations, I think this is the easiest way to do this. I mean, there are other approaches, but this is, in my opinion, the simplest and a useful fallback if you have tables with clob columns you want to compare. All right, then I'll reset things. Any questions or comments on this before we wrap up? Yes, I'll be sharing scripts and stuff. Yeah. Let's just reset and remove the clogs and stuff to keep things nice and clean and simple. Any other questions or comments before we move on? Alrighty then. So let's just recap on that kind of quickly and see what we looked at. So as we started off with, we can use set operations to compare them. Actually, there's a few ways you can write that. There's other ways you can do the comparison as well, but I did table 1 minus table 2, the reverse, and union them together. That is null safe, so if there are nulls in any of the columns, it will work, but it does ignore duplicates by default. We can fix that with minus all in 21C, and if there are any lob columns, they will break it. You need special handling for those. When it comes to the full outer join, again, nulls break by default. You need to kind of manually write MVL or have null handling in your join clause if any of the columns could be optional. And again, by default, it ignores duplicate values in either thing. If you have not lob columns, however, comparing JSON using JSON equal is a nice, simple way to do it. Then there is my favorite approach, the group by method. So two big advantages for me, at least, is it's null safe, and it shows duplicates by default. You don't need to do anything special to show extra rows in one table and not the other. However, the big downside, and lobs rearing their head again, they will break it by default. You'll need special handling if you want those to be able to compare directly. So we've got 3 different approaches here, and there are actually other ways you could compare as well. So you might have a favorite approach, and you probably want to actually be able to kind of wrap this logic in a function, so you don't have to think about it every time. There's lots of little traps and things and gotchas to kind of catch you out here. So the question here is, can we just make this into a reusable function? Can we define a function which does the comparison, so we don't need to think about which of these methods we're using? We'll just define it once. So this is where SQL macros come in. One of my favorite recent features, I should say, in Oracle database. So something that, well, it was originally a 21C feature, but it's been backported to 19C. So as long as you're on 19C and fully patched and up to date, you can use these. And what you can use these for is to essentially create query templates that we can pass tables and columns to at call time, and the database will convert that into the corresponding query. So we're going to create our compare tables function. We'll pass in our tables, T1 and T2, and our list of columns from them we want to compare. Notice we're returning a SQL macro, and that is text. And that is basically the template query as a string, okay? And that could be whichever of these methods you want to use: set, operations, outer join, or group by. Really depends whichever one you want to go with. Then to use it, we just call compare tables and pass the table and the columns in. Nice and simple, right? We don't need to worry about the insides of the function and how it all works. I realized that's a very brief introduction to SQL macros. There's a lot to talk about them. If you want to know more, I talked about them quite a long time ago, office hours like June 2020. Check out the recording of that if you want to know more about SQL macros, because there's a lot to talk about them. But suffice to say, they're a great way to kind of make that kind of query template. So we can compare our tables like that. So having built our function, then the question is, what other ways could this be useful? So we saw it's useful if we're just kind of comparing one table to another, but there are other situations where this could be handy. Say, for example, you are tuning a query. So let's say we've got a nice big SQL statement like this. You've been called in to optimize it, make it faster. So you've rewritten it to this. The question here now is, are these queries the same? Or, well, they're not the same, but do they return the same results? Are they functionally equivalent, right? So the way to check that is to basically do the query difference on each one of them. Now, we could just paste the entire query into each of your own favorite methods, either as its with clause or as an inline view. That can get a bit fiddly, right? It can make the SQL statements a bit hard to manage. Even the statements we had before, which are reasonably large, imagine one which is a few hundred lines long, can get quite messy. So something I like to do in these situations is use views. Basically, just create a view for the old and the new queries, wrap them in a view, and then we can just pass those views to our comparison method. We've got our compare tables macro here, or we could just do it in group by or whatever. This is something I use quite a lot to, whenever I've changed a query, I want to check, does it return the same results? And, this is also useful, not just if we're tuning a query for performance, but maybe we've got a query, you're adding columns to it, which means you need to join in a new table, right? So we know the new columns are going to be different because they're not in the old query. But the question is, are the existing columns, are they still returning the same data? Right, that's an important thing to verify. So we can create those views and just compare the columns, the old columns, the original columns, and make sure they are the same. So that's, again, this is something I've used this table comparison for quite a bit. Another thing that might crop up is what's changed, right? I'm sure most, if not all of you, have experienced that lovely, joyful moment when you get the call or the Slack message or whatever, where somebody's deleted data they shouldn't have done, right? Oops, bit of finger trouble. They've accidentally deleted the wrong rows, and you need to recover them, right? And the question here is, well, first up, how do you know what was deleted, right? How do you get the values back, right? And this is where flashback query comes in, very, very useful. So you can use this to see how the data as it's existed in the past. Select star from table, as of timestamp, sysdate minus however far back you want to go. And I say however far back, this is limited by undo. By default, you're only guaranteed 15 minutes. You might get longer, but you're only guaranteed 15 minutes by default. If you want a bit more margin, then you need to speak to your DBAs to make sure you've got a bit more wiggle room there. But this shows us the table as it was in the past. So we can compare the current state, just table current state, to the old state. Very useful to get the delta and find, okay, this is what we had before, this is what we got now. What do we need to change to fix the data or restore the lost data and cover that information, make it available again? Now, at this point, it's worth noting there's actually kind of two versions of flashback query. The as of timestamp, where we view data as it was at a point in time in the past. So this is a point when we know the data was good, right? You ask the user and say, well, when did you run the delete? And then go back a little bit before that. You can also use the versions between syntax to see all the changes over time, right? So this shows you something similar, but slightly different as well, because this shows you all the individual DML operations, insert, updates, and deletes. And this can also be useful, but it's not quite the same thing. In particular, let's say someone inserted a row and deleted it. They inserted it by accident and genuinely wanted to remove it. That will appear here because it's two operations. But if we're comparing the old and new tables, we don't see it. Also, if someone's made lots of updates to a row, we'll see all the individual updates here, right? We'll see every single change. Whereas if all we care about is the old state and the new state, we don't necessarily want to do that. We'll just see the point in time in the past, compare it to now. So both of these have value, but they work serve slightly different purposes and slightly different uses. Finally, and this cuts across all of these, and let's say something I was saying about earlier, let's say a row exists in both tables, but only one or two columns are different. It's particularly important to know if you've got a table with lots and lots of columns on them. So you need to see what the changes are. So you can run the update or tell the user, this is what's changed. What do we need to do here? That kind of thing. So in order to do this, what you want to do is unpivot the data first. So unpivot takes a list of columns and turns them into rows. And we can do that with the unpivot clause. Unpivot, so it's the value from the columns for column, and so a list of columns here. And so for each column we list, we will get a row in the output. So what we can then do is compare each of those column rows. I'm not sure that's the right terminology for it, but hopefully you understand what I mean. But then we can compare each of those columns as rows and so unpivot each table first and then do the comparison. And then this only shows us the different values on a column level from each table, which again could be quite useful in some cases when you just want to know exactly what specifically is different. Tables with lots of columns on them. So at this point, I'm going to jump back to a demo and kind of show all these in action. I see there's been lots of questions, lots of things on the chat coming through, so I'll just check these quickly. Generic Google search on multiple columns. I'll come back to that a bit later. Is where to compare tables across different database or PDBs. So yeah, comparing across databases is a good question, actually. If you've got a database link between them, then you can run these queries across the DB link, right? And that's the basic way. If there's no database link, then you have to find some way to kind of load them into a common area, okay? So that's comparing across databases. Comparing across PDBs, I think if you're in the container, there are ways to do it, but I can't remember off the top of my head. Yeah, I'd have to check that, right? So comparison comment. I once used comparison of several tables using union, all, and rank with few more conditions, like choosing only relevant columns from comparison. Yeah, that's good point, actually. You know, we've talked about two here. You could use it for multiple. So yeah, if you've got any other use cases or examples, please share them. All right, so let's see. Anyway, let's move on with the demo. So I'm going to build my macro to compare the tables. As I said, we've got our string, which is the query template. So hopefully you can look at this and it looks a little bit like the query we had before, right? You can see we're going to paste in or swap in our column list, and we've got our table names. The database will automatically swap in the table names. We need to manually do the column names. Again, you want to know more about that, you'll have to catch up on the recording from the other session, because there's too much other stuff to talk about today, right? Okay, so let's create our comparison and compare macro. And just kind of prove it works, we've got our compare tables, jobs to job stage. And again, this looks right. Yeah, we've got let's just sort by that. You can see we've got our differences there. So we can use this. It's a nice, simple way. And, you know, it doesn't really matter which method you use in here. It's up to you. You can choose that and have some logic in there to do what you want. All right, so let's compare some queries. So let's say, here's this old query, and I've got a lot of scalar subqueries, which means this jobs table appears, let's see, 1, 2, 3, 4, 4 times in this query. Ooh, that doesn't sound good, right? You know, if you've heard me talk about SQL performance, you say one of the big things is try and query each table just once, right? You want to avoid multiple references to the same table as much as possible, so we're not reading unnecessary data. So let's fix this, right? So there's a couple of things we'll want to do. Rather than scalar subqueries, we'll turn these into window functions. And actually, we're going to change this from a subquery we've got on employees, turn that into a join, an outer join, actually, because there might be jobs with no employees. So let's see. So here is our optimized query. Notice we've converted all those scalar subqueries into analytic functions. We've joined to jobs and we count the employees. So we've got our two things there. Like I say, we could just then paste these directly in our queries, but that leads to quite large queries already, and these aren't that big a SQL statement, right? So what I'm going to do is just wrap them each in a view. There's my original query, there's my new query, and the question now is the million-dollar question: are they the same? We're just tuning these for performance; they should be identical. And whoopsie, I made a mistake here. Right, the employee count is different. What's going on here? Why is the employee count different here? Right, so I'll just kind of remind you, before we were counting all the employees with that job as a scalar subquery. Now we've turned it into an outer join and just counting count stars. Like, huh? What? Why is that different? What's going on here? Why? What's the problem here? Well, when we do count star, that returns one for at least one for each row. We've got a row for every job, but we want to count the number of employees for that job. So this is counting the rows. What we want to do is count the employees for those rows, or the employee rows. So we need to change this to like e.jobid, the column from the employees table, because if there are no employees for that job, that will be null, and this only counts the non-null values. So we do that, fix it, and just check. Have we actually fixed it? Is it now right? Yay! We got no results. All right, so we fixed our query there. So, like I say, very useful way when you want to compare complex queries or old and new versions of complex queries. Stick them in a view and then use your favorite comparison method. Makes things much easier to manage. All right, let's just to show our original tables, we have some differences. I'm going to run a merge. let's say this is actually a normal process. This is some staging area and it's, some data load, putting the data in the stage and then copying it into the main table. And I'll do that with a merge. Let's commit that. So the question here is, what has now changed? We've changed a whole bunch of rows in the jobs table, but what are the differences, right? So this is, again, we'll check. There is one row that's still different because this row, the accountant was in jobs, but not in job stage. So it didn't remove anything. But we want to show the differences. So let's see. We'll see the job as it was in the past. So 122nd, 2 minutes ago, this was the state of the table. So we can put that in a subquery to compare the current state with the old state. There we go. Voila. We can see. So T1, if I remember which way around this is. Let's see, hang on, I'll remind myself. 2 minutes ago, IT programmers were paid max salary 10,000, right? So current state, 15,000. So T1, these are the values that are in the table now that weren't in the table then. So again, like it could be useful again to verify data loads, or people have some finger trouble and they've updated or deleted the wrong data and you need to know how it existed in the past. So like I say, this is a point in time. So that's the exact state. You can use this versions of between syntax to find all the changes, but this is a bit different. Notice, so this merge, it does change all the rows because they all match. But I say I'm putting change in quotes because a lot of them, the values were identical. So it didn't actually update anything. You can see, with our comparison, we only got 2 rows different, but we're getting an entry in this versions between for every single one of those update operations. Okay, so this shows you all the DML operations. Super useful for in some cases, particularly for debugging or figuring out what the heck happened. How did we end up in this weird, wonderful state? Maybe not quite so useful if you're like, okay, this is the data now. This is the data as it was then. Just make it look like the data now look like then. Okay, we just want the delta. So they both have a scenario and a use case. Okay, and finish up, we'll look at the column differences. So yeah, we can unpivot it. Now, notice I'm first having to char the number columns. That's because they've all got to have the same data type. These columns we are unpivoting, and I am only unpivot. I'm not including the job ID, which is in theory the primary key. I haven't actually made it the primary key, but it's in theory it's the primary key. Why? Well, because we need that. We need this to actually do the comparison. If we just have all the columns and values, then we don't know which row they're associated with. We need to know that the president has these values, the president job, the IT programmer have these values. Then we can do the column level comparison for each of these. So we'll just paste those in, we'll unpivot. What have we done here? Again, old and new before. So as it is now, as it was before, what are the column level differences? So we can see more easily now the IT programmer there. We've changed the max salary. Nothing else has changed. With our SA rep, this is a new row because there are no rows for T2 in it, right? So we know the whole row is new here, and we can maybe add some extra filtering or whatever if we want to deal with that. So we've looked at table comparison methods. The obvious thing is comparing actual physical tables, but we can use them to compare queries as well. If you're doing that, personally, I really like to turn them into views first. It just makes it much easier to write those queries. We can also use these comparisons to define what's changed in a table over time. And I can say from experience, this has personally saved me, or well, maybe not me specifically, but the users of the systems I've supported many times, because I've got them out of trouble, been able to restore the data that they accidentally deleted. And finally, if you want to see the column level differences, the same rows exist in both tables, but some of the columns are different, and which are which, right? Can be super hard to see. Unpivoting them first and then doing a comparison allows you to see each column as rows and just spot those column level difference more easily. Alrighty then, to finish up, we'll talk about performance. And the whole kind of reason we started going down on this wonderful journey and look at all these other things was, I was saying, with the classic approach here, I mean, there were a few limitations like duplicates and stuff, but a big drawback is we're reading all of both tables twice, right? That sounds like a lot of unnecessary work, right? So the question here is, well, which of these is faster, right? So I think the only thing to do in this situation is actually run a demo. Okay. So I'm just going to load up some more data just to make it get things moving a bit. So we've got just a little under 100,000 rows in each table. I'm going to add primary key, and then I'm going to do the comparisons. I'm going to start this running because it'll take a few seconds. Each comparison about 5 times, just so we can, there's a bit of variation in them. So we're going to loop through. So here's some I made earlier with my SQL macros. I guess you'll just have to kind of trust me a little bit. So the set operation macro using group by, a natural full join or just full join, I can't remember, and then the JSON comparison method. Okay, and there we go, that's finished. So we'll go through and bring this all up. So first thing to notice here, the JSON method is definitely notably slower than all of them, right? It's about 10 times slower, right? In the order of 10 times slower for each of them. So the JSON method, comparison method, is definitely much slower than. And if you think about it, it's having to compare the full JSON document, whereas the other methods can compare individual values, columns, and start eliminating or finding differences more easily. So let's say I'm showing you the JSON one because it handles lobs straight away with no extra special handling. And this is probably the only scenario where I'd actually consider it. Okay, so that's JSON. It's definitely slower. But something interesting is going on here. If we start looking at some of these other ones, well, we're saying with set operations, we're reading the tables twice, and the other ones, group by and full join, we're reading them once. Set operations be like roughly twice as long as these other ones, right? But it isn't. It's kind of roughly the same amount of time, right? And in some cases, it might even be the fastest, slightly faster. And it's like, oh, that's interesting. Yeah, set operations, it's the fastest one here. What's going on, right? What is going on here? Well, let's run a bit more. Let's add a bit more data in, and I'll run the comparisons again. I'll exclude JSON this time because so we're not here all day, right? We will be here all day if I start including the JSON in some of these other comparisons. So we're just doubling everything up again 3 more times. So we'll have a lot more data in here. There we go. And it goes, and I'll run the comparisons again just 3 times this time. See, like I say, maybe it's just an artifact of the fact it's fairly small data sets, right? So let's load some more data in and see what happens, and see what actually goes on there. So while that's running, I see this question: when we use SQL templates, how does the SQL plan look like? It's exactly the same as if you had written the query manually. So with SQL macros, it is just a template. Take that template, swap out the column and table names. It is that query. So it is exactly the same plan that you would have gotten if you'd written the query manually, right? It is essentially transparent to the optimizer. This is just a simplification. So it's a reuse thing, okay? So yeah, SQL macros perform identically to running the base query itself that it is based on, okay? All right, then. So we've run that and say, okay, if we've loaded some more data up, maybe it's an artifact of small data set or something. But actually, you can see, again, they're all coming out pretty similar. I mean, if anything, the group by might be slightly slower. Maybe the full join is slightly faster. But set operations definitely isn't twice as slow, right? It's like, oh, what's going on there? Why is this? Well, first thing here is there are a lot of differences between the tables, right? I'm comparing the tables, and there's actually what 1.4 million different rows between the tables. Okay, that sounds a bit extreme, right? Usually if you're comparing tables, you hope they're identical. And in worst case, you might expect like a handful of differences. You don't expect 1.4 million rows worth of difference, right? So the truth is, I'm honestly not entirely sure exactly why the set comparison comes out so well in this scenario. I have a couple of hypotheses. One is that the database has a lot of inbuilt caching and optimization. So when it's querying those tables, it isn't necessarily actually full scanning all of those tables twice, or like fully reading all the data twice. So it has various caching and optimization. So it isn't necessarily doing that. But the second thing is when we've got table 1 minus table 2 and the opposite, each of them is essentially only processing half of the data. Whereas with group by and full join, they are combining everything into one large data set and processing all the duplicates as one. So that's a bit of a theory of mine. I'm not entirely sure, but there is an artifact here, and it is we do have a lot of duplicates. All right. Let's change things up. Let's make the tables identical. So I'm just going to truncate the jobs and load in everything from job stage. So now there are no differences between the tables. And let's rerun the process. And we'll run it 5 times. This will be a lot faster, mostly because we're processing less data, returning less data, I should say. There's going to be 0 rows output from each one. So this is going to transfer away, and hopefully, there we go in a second. And now we can see, now when there are no differences between them, actually set operations is roughly in the order of taking twice as long as the other ones. Okay. 1.4 seconds, maybe not exactly twice as long, but roughly in the order of twice as long. Okay. So it doesn't just matter how we're doing it also matters how many duplicate values there are and how many rows we're actually processing. And this is just when we're comparing straightforward tables. Let's compare those queries. So first up, I'm going to delete a whole bunch of data. Those of you who are not familiar, this is a really simple, neat way to delete a huge amount of data from data table, add it in 12.2, move, including the rows, so basically leave everything else behind. If you want to delete most of the rows from a table, this is a really, really neat trick, which is super easy to do. So we got much smaller data sets now. There's like less than 50,000 rows. I will, just to prove it's not an effect of there being no differences, we'll compare our old and new queries. And I'm just going to run this once because it's going to take a little while. So we can see it's not just the query we run, but it's the number of duplicate values we get affects things. So the upshot here is there's no simple answer when it comes to performance. Like most things with performance, there's no easy answer. JSON is definitely slower, but beyond that, exactly which is faster and by how much will depend a lot on your data. How many columns there are in each table, how many rows there are, how many differences there are between each one. So do test and run it on your own data. While I've finished gibbering, it's fine, it's finished, and now we can see when we're comparing those queries, the set operations is definitely notably slower now. So it is down to taking roughly twice as long. So like I say, the group by is still my favorite because it is probably the most consistent usually. But again, if you care about performance and performance really matters, this is an ongoing thing, do test and check on your own data. Okay. Any last questions or comments before we wrap up? Well, while you're just saying any questions or comments, there was someone asking about the scripts. If you want the scripts, here they are. They're on Live SQL. Follow the QR. I've also added them to the links, the resources on the page. So if you go back to the office hours page where you viewed this, you'll see a link to the scripts there. I've also this morning published, put all this in blog form as well. So I've talked through all of this and very similar stuff, but I've put it all in the blog to kind of explain how that all works. Again, you can check that all out. Finally, here's a little kind of cheat sheet showing you how they all work and the kind of differences between them all and how they all actually work in practice. Okay, so next office hours is due on Tuesday, the 21st of November. So if there's anything you'd like us to talk about then, please get in touch, let us know. Otherwise, I really hope you enjoyed this. More importantly, I hope you learned something, and I will see you next time. Goodbye.